So this will be the last practice test for the semester because all we have left after this is Chapter 9. And in Chapter 9, there isn't an in-class test. There's just a take-home assignment. You don't have to turn in homework. You just have to figure out how to do the problems on the take-home assignment, probably by watching the videos. And then you just turn that assignment in. It's worth 50 points. And that's the last thing you'll have to do unless you're lucky enough to have to take the final. I'll talk about in class how the final works and whether you do or don't need to take it. So problem 1 on this practice test wants me to solve using substitution. Ultimately, what I'm going to do is I'm going to change the x in the top equation to y minus 1 because the bottom equation is solved for x, and I'm given the option of solving this using either the substitution method or the elimination method. And the substitution method is definitely the better method to use if you have one of the two equations solved for a letter. More often than not, students that get this problem wrong on the test leave the top equation how it's written, and it's just a bad idea. So before I start doing my substitution, I'm going to modify the top equation, and I'm going to multiply every term in the top equation by 12, specifically because 12 is the least common denominator between the two fractions that I see. And now I can clear the fractions. I'll not clear the fractions in one step, I'll do it in 2 steps. Anytime I'm multiplying an integer by a fraction, you can think of that integer as a fraction with a 1 in the denominator, and you could just multiply that integer by the numerator, because really 12 times 2 over 3 is the same as 12 over 1 times 2 over 3. And to do that multiplication, you multiply 12 times 2 and get 24, and 1 times 3 and get 3. So I'm going to rewrite the first fraction as 24 over 3 times x. Second fraction, I'm going to go 12 times 1, which is 12, 1 times 4, which is 4, and make that 12 over 4 times y. And on the right side, I'm going to multiply the 12 times 3 and get 36. Now I'm going to simplify the fractions, although I could have simplified them earlier. It's just that a lot of times students like to see this extra work with the fractions just to see kind of what I did. So now I have an equation that I'm going to change the x to a y minus 1. I certainly could have, in the top equation, changed the x to y minus 1, but that was going to cause a lot more work than I care to do, because I don't like to work with fractions. And when problems have equal signs in fractions, you can get rid of the fractions. So now I've just changed the x to y minus 1. I'm going to clear the parentheses by multiplying the 8 times the y and the 8 times the minus 1. And then on the left side, I'm going to add the 8y and the 3y and get 11y. I'm going to get the 8 to the other side by adding 8 to both sides. And then I'm going to divide by 11 and get part of my answer, but not my whole answer. This answer needs to have both an x and a y. I have the y. I'm going to get the x by changing the y in the bottom equation to 4. I could have changed the y in the top equation and to 4 and solve for x, but the easiest way to solve for x was to do what I just did. My answer to this problem I'm going to write as a point. I'm going to write the x first and the y second. And that's all there is to do for this problem. I'm just kind of checking it in my head, and it seems to work just fine. When I go to do problem 2, I'm going to wind up using the elimination method. Of the two methods that we're allowed to use for problems 1 and 2, the substitution method is preferred if one of the equations is solved for a letter. The elimination method is preferred if the letters are lined up, and that's the case for problem 2. The letters are lined up just fine. What I need to do to use the elimination method is get the same number with different signs in front of one of the letters. My options for this problem, and they're equally good, is to leave the top equation with the bottom 3x and create a negative 3x in the bottom equation. That's probably the easier option because it takes only one of the equations need to be changed. The other option would make the top have a 10y and the bottom have a negative 10y. That would be equally good for the elimination method, because to do the elimination method you have to have the equations sitting on top of each other, and you have to have one of the letters with the same number with opposite signs, and both of these strategies will work. This bottom strategy would involve multiplying the top equation by 5 and the bottom by 2, so I have to change two equations. This top strategy only requires multiplying the bottom equation by negative 3. So I'm going to choose that strategy. I'm choosing this strategy as opposed to the second. They both ultimately will give the same answer. So to use the elimination method, my strategy is only going to have to change the bottom equation by multiplying negative 3 times x and getting negative 3x, by multiplying negative 3 times negative 5y and getting positive 15y, and multiplying negative 3 times negative 7 and getting positive 21. Now that I have what I desired, I'm going to add the equations together. The x's are going to drop out, and then I'm going to go 2y plus 15y is 17y, 21 plus 13 is 34. I'm going to divide by 2 and get y equal to, I'm going to divide by 17, and get y equal to 2. 17 is the number in front of the x. 2 winds up to be the answer. Now I need to solve for x, and to solve for x, I can plug y equal to 2 there, or there, and they all will give the same value for x. I like plugging y equal to 2 here because the x is going to be easy to solve for. But any of the places where I marked the y, you could plug y equal to 2 and you'll get the same answer. But I'm going to choose the x minus 5y equal negative 7 equation. I'm going to plug in 2 for y. That's going to give me x minus 10 equals negative 7, and I'll just add 10 to both sides. And that's going to give me x equal to 3. My answer for this problem is going to be x equal to 3, y equal to 2. Anytime I use the elimination method to solve a problem, it's super easy to check doing the RREF on my calculator, even though if you use RREF on your calculator and don't show any work, you won't get any partial credit. You'll get completely no credit. You can certainly check. So if I wanted to check this problem, on my calculator, I'd go second in matrix, I'd bounce over to edit, I'd hit enter, and I'd take the coefficients after I type in 2 by 3. I'd take the 3, the 2, and the 13 from the top equation and make the top row, and then the number in front of the x, 1, negative 5, and negative 7 from the bottom row. After I have the matrix in, you hit the second in the mode quit key. Then you hit second, matrix again. You go over to math, either up or down till you find RREF, not REF. Hit enter when you hit RREF, and then second in matrix another time. I hit enter on A, close my parentheses. When I hit enter, the numbers in the right hand column are going to be the x and the y for my answer. Should be 3 and 2 in that column, and there's perfectly there the 3 and 2 that I hope to see. Problem 3 is the nasty problem, and I might as well know what my answer is ahead of time. And again, if you don't solve the equation by hand without matrices, which are the instructions for this, you'll get 0 points even if the answer is correct, but I might as well get the answer. So to get the answer to this, I'm going to enter a matrix on my calculator by going second, and then the matrix x inverse key. I go over to edit. When I hit enter on this, there's 3 equations, so I'm going to type 3 first. And there's 1, 2, 3, 4 columns, one for the x, one for the y, one for the z, one for the 17. So I'm going to type 4 and hit equals. In the top row, I'm going to type 2, 4, -5, and 17. For the middle row, I'm going to type -1, +1, +2, and -5. And for the bottom row, I'm going to type 1, -3, +3, and -2. I have the matrix representation of this system of equations. Then I go second and quit, and then second and the matrix X inverse key, over to math, down to RREF, hit enter on that, then second and matrix key, I hit enter on names, and whether I do or don't close the parentheses, it doesn't matter. The numbers in the right hand column are going to be my answer. My answer to problem 3 is going to be 4, 1, and -1. You essentially get 0 points for the correct answer and probably 10 points, which I think this is worth for the work. So let me go ahead and do the work by hand that needs to be shown. And my instructions said pair the middle equation with the other two and drop out the x's. So I'm going to take this middle equation, I'm going to write it down twice. I'm going to write it down once with the top equation. So this is a middle equation paired with the top equation. And then I'm going to write it down a second time, and this time I'm going to pair it with the bottom equation. And for each of these, I'm going to do the elimination method and drop out the x's, because my instructions say pair the middle with the other two and drop out the x's. In this left set to drop out the x's, I'm going to make the x's have a positive and a -2. By multiplying the top equation by 2, I can get the -2 in the top to compare with the 2 in the bottom. So for this top, I'm going to multiply everything here by 2. 2 times -x is going to be -2x. 2 times positive y is going to be plus 2y. 2 times plus 2z is plus 4z. 2 times minus 5 is minus 10. I'm going to leave the 2x plus 4y minus 5z equals 17 alone, and now I'm going to combine the equations. I'm going to add, and the x's are going to cancel because they're opposites. 2y plus 4y is 6y. 4z minus 5z is minus 1z. You don't need to write the 1, but you can. And minus 10 plus 17 is positive 7. For the other pair of equations, I can just add them together and the x's will drop out. So I'm going to combine these without doing any multiplying first. X's are going to drop out. Then I'm going to have 1y minus 3y is -2y. 2z plus 3z is positive 5z. And minus 2 and minus 5 is minus 7. So that's kind of my first step. I have to do the elimination method 3 times when I'm doing these by hand. Let me do the second step in a different color. To do my second step, I'm going to take each of the answers that I came up with on the first step, the 6y minus 1z equals 7, and minus 2y plus 5z equals -7, and I'm going to solve these like I did, I guess, problem 2. And I'm going to solve them by dropping out the y's. I'm going to multiply the bottom equation by 2. I'm going to leave the top equation intact, and that's going to let the y's drop out. So I'm going to get 6y minus 1z equals 7, again for the top equation. I should be multiplying the bottom by 3 and not 2, because 3 times -2y is -6y. 3 times positive 5z is positive 15z, and 3 times -7 is -21. When I combine these, the 6y's cancel. -1z plus 15z, I forgot the z, is going to be positive 14z. And 7 minus 21 is -14. I'm going to divide both sides by 14. And that's going to give me the z equal to -1, which is 1/3 of the answer that I need. So that's that part of the answer. Now I'm going to continue working in pink, and I'm going to solve for y. I can pick any of these two equations to solve for y, and neither one of them are that desirable. But I'm going to solve for y by using this equation. And in this equation, I'm going to change that z to a negative 1. So I'm going to go 6y minus 1 times negative 1 equals 7. The double negative I have here turns out to 6y plus 1 equals to 7. I'm going to minus 1 from both sides. That's going to give me 6y equals to 6. And then I'm going to divide both sides by 6. And that's going to give me y equal to 1, which is that part of the answer. The only thing I need to accomplish now is going to be my third step, and I'll do my third step in yet another color. I'm going to solve for x. So my first step is in blue, my second step's in pink, and my last step is to solve for x. I can pick any equation that I see that has an x. I'm going to pick this equation to solve for x, and in this equation I'm going to change that y to a 1 and that z to a negative 1. The reason I'm picking this equation is because the x doesn't have a number in front of it, and it's going to make it easier to do. So when I go to solve for x, I'm going to go x minus 3 times 1 plus 3 times negative 1 equals to negative 2. This is going to give me x minus 3 equals to negative 2. That's going to simplify to x minus 6 equals negative 2, and then I'm going to add 6 to both sides. On the left-hand side, the 6's cancel, I'll get the x, and on the right-hand side, I'll get the 4, which is the last part of my answer. So that's everything that I need to do for problem 3. Again, the answer is kind of worth 0. All these steps that you take to get the answer are where the points are going to come from. Question 4 is doing matrices by hand. It's to solve this system of equations using matrices and row operations. 0 points if no matrix works is shown, even if the answer is correct. So what I need to do this by hand is I need to create a matrix. And usually when I create a matrix, I write the problem without the letters, and I leave a bar where the equal sign was just to kind of separate it. Step 1 is going to be to eliminate the x's and make a new bottom row. So in a second here, I'm going to come up with my second matrix. I'm going to make a new bottom row, so I'm going to leave the top row the same. To eliminate the x's, I need to get the numbers in the first column, which is the x column, to have the same numbers with different signs in front of them. And what I'm going to do is I'm going to make the top equation have a 6 in front of the x position by multiplying everything in the top equation by 2. And I'm going to make the bottom equation have a negative 6 in front of the x by multiplying every number in the bottom equation by negative 3. So this is going to transform to 2 times 3, which is 6, 2 times 2, which is 4, 2 times 16, which is 32 for the top row. And then bottom row, negative 3 times 2 is negative 6. Negative 3 times negative 3 is positive 9. Negative 3 times negative 11 is positive 33. When I add these together, I get 0, 13, and 65. I can make this for my bottom row, but I probably don't want to do that because the numbers are so big. And every number in that row is divisible by 13. So I'm going to go ahead and do that division. When I divide all those numbers by 13, I'm going to get what my bottom row is going to be. 0 divided by 13 is 13. 13 divided by 13 is 1. 65 divided by 13 is 5. So done with the first step, I eliminated the x and I made a new bottom row. Second step is I'm going to eliminate the y and make a new top row. To eliminate the y's, I need to get the same numbers in the y columns with different signs, and I'm going to do that by just making the y's have a negative and a positive 2 in front of them. I'm going to leave the top row at 3, 2, and 16, and I'm going to make the y in the bottom row, which is in the second column, cancel by multiplying by negative 2. I'm going to go negative 2 times 0 is 0. Negative 2 times positive 1 is negative 2. Negative 2 times positive 5 is negative 10. I'm going to add the rows together. 3 plus 0 is 3. 2 minus 2 is 0. 16 minus 10 is 6. I'm going to divide all the numbers by 3 because they're divisible by 3, and that will make for a better next matrix. 3 divided by 3 is 1. 0 divided by 3 is 0. 6 divided by 3 is 2. And now I'm going to transfer that, write that in my top row. So my top row is now going to be 1, 0, 2. My bottom row is 0, 1, 5. And now I can write my answer. My answer is going to be x equal to 2, y equal to 5. I'm going to double check that by entering this matrix on my calculator, and I'll do RREFA real quickly. So real quickly, to make sure 2 5 is the right answer, I do second matrix over to edit. This has 2 rows and 3 columns, so I type 2 and hit enter, 3 and hit enter. The top row is 3, enter, 2, enter, 16, enter. Bottom row is 2, enter, negative 3, enter, negative 11, enter. Done with entering the matrix, I go second quit, then second and the X inverse matrix key, over to math, down to RREF, and then second matrix, enter on names, and hit enter again. I see exactly the matrix that I got, and I know the numbers in the right-hand column are the answer. So that's perfect. 5 and 6 I'm going to do by hand, but you can use your calculator to do these. 5 wants me to do 2 times D, which is 2 times the D matrix, 3, 2, 0, 4, negative 1, 3, minus the C matrix, which is 1, 0, negative 1, 7, 2, 4. Have to do multiplication first, and this is scalar multiplication. To do 2 times D, I multiply every number in the D matrix by 2. So 2 times 3, 2 times 2, 2 times 0, 2 times 4, 2 times minus 1, and 2 times 3. So there's 2D minus C, and now I'm going to do the minusing by going 6 minus 1, 4 minus 0, 0 minus negative 1, 8 minus 7, negative 2 minus 2, and 6 minus 4. My answer, I'll just do it in a different color so we can see it better. My answer, 6 minus 1 is 5, 4 minus 0 is 4. This double negative turns positive, so I get 0 plus 1, which is 1. 8 minus 7 is 1. Negative 2 minus 2 is negative 4, and 6 minus 4 is 2. That's all there is to do for that. You can absolutely do that on your calculator. Let me show you how to do that on your calculator really quickly. I'm going to enter matrix D and matrix C on my calculator. To do matrix D, I go second in matrix, go to edit, down to D, and that's going to be a 2 by 3 matrix. I'll type 2, enter, 3, enter, and then enter the numbers 3, 2, 0. I already have 4, negative 1, 3. I've got that in. Now second and quit. Let me clear out the screen. Then second matrix, over to edit, down to C, hit enter, type in 2 by 3 and enter it. I already have it entered in there. So once you get to this screen, you just enter 2 by 3, you get the matrix in. So in my matrix C, I have that matrix. In my matrix D, I have that matrix. Let me second and quit. To do 2D minus C, super easy. I just type the number 2, and then I do second and matrix. I stay in the names column. I don't go over to RREF, and I just hit enter on D. This is the 2D for my calculator. Now I'm going to do the minus sign, and then I need to get the C after that using the matrix names. I just go second matrix, down to names, hit enter. When I hit enter, it's going to give me the answer, and hopefully it's exactly that. 5, 4, 1, 1, negative 4, 2, so I feel real good about that. 6 I don't like at all. 6 is a mess to do by hand. Let me do it on my calculator really quickly. I'm going to enter A on my calculator as a 3 by 2 matrix, and I already have C on my calculator. Once I have A and C entered, I can find AC really easy. So let me do this real quickly. Enter A, so second matrix, edit. This is a 3 by 2 matrix for A. I'm going to go 1, enter, 0, enter, 3, enter, 2, enter, 6, enter, 1, enter. Feel good about how I have A in. Second, quit. Now to do AC on my calculator, it's just the names, it's not the RREF. I start off going second matrix, hit enter on the names A, and then second matrix, hit enter on the name C. It's going to give me a big old matrix. The answer to this is going to be 1, 0, negative 1, 17, 4, 5, 13, 2, negative 2. The instructions for problems 5 and 6 on the test say do it on your calculator, you'll get full credit even if you don't show work. Just because I can't foresee anyone needing the matrix multiplication unless you're like in a second semester brief calculus. No, not even that. It may be in a Calc 3 class. It just doesn't come up that much, so it's not the most important skill to be competent with. To get the answer by hand, I'd have to write matrix A down and next to matrix C. And I'm going to get my answer one row at a time. So first I'm going to get the top row by writing this 1, 0 vertically next to each of the 3 columns, the 1, 7, 0, 2 and the 1, negative 4. So I'm going to write the 1, 0, which is the top row, next to the 1, 7 column. I'm going to write the 1, 0 next to the 0, 2 column, and I'm going to write the 1, 0 next to the negative 1, 4 column. And when I do this, I multiply across and then I add. So I'm going to go 1 times 1 is 1, 0 times 7 is 0, 1 plus 0 is 1. And then I'm going to go 1 times 0 is 0, 0 times 2 is 0, 0 plus 0 is 0. Lastly, 1 times negative 1 is negative 1, 0 times 4 is 0, negative 1 plus 0 is negative 1. The top row is going to be 1, 0, negative 1, which is 1, 0, negative 1. I'll move on and do the middle row. I'm done with this 1, 0. I'm going to move on to this 3, 2. To get the middle row, I'm going to go 3, 2 times this 1, 7, and then 3, 2 times this 0, 2, and then 3, 2 times the negative 1, 4. I'm going to multiply across. 3 times 1 is 3, 2 times 7 is 14, add 3 plus 14 is 17. Multiply across. 3 times 0 is 0, 2 times 2 is 4, add 0 plus 4 is 4. Multiply across. 3 times negative 1 is 3, 2 times 4 is 8, add, but they have opposite signs, so I'm really subtracting, and I get 17, 4, and 5, which is this 17, 4, and 5. Barely have room to get this bottom row, but to get the bottom row, I'm going to take this 6, 1 and do the same thing. I'm going to go 6, 1 times 1, 7. I'm going to do 6, 1 times 0, 2, and 6, 1 times negative 1, 4. I multiply across. 6 times 1 is 6, 1 times 7 is 7. I add and get 13. I multiply 6 times 0 and 1 times 2 and get 0 and 2. Add and get 2. Multiply 6 times 1 and get negative 6. 1 times 4 and get 4. Those have opposite signs, so I subtract and get negative 2. And that 13 to negative 2 is that. So this is the answer. And you don't have to do matrix multiplication by hand, but you certainly are welcome to do it by hand. Problem 8 wants me to use Kramer's rule, and the problem on the test I think is worth 10 points. And to do Kramer's rule, you have to find 3 determinants and 2 answers. On the test, if you get the answers and don't use Kramer's rule, you're going to get 0 points. And if you don't calculate each one of these determinants and you use Kramer's rule, you wouldn't have done it right, you won't get any credit. So first thing I need to do is calculate the D determinant. So the D determinant I get by taking the coefficients of the x's and the coefficients of the y's, and I write them down in a matrix, and I'm going to cross multiply down, and I'm going to cross multiply up. Now I'm going to subtract these amounts. So I'm going to go 9 minus negative 4, which is 9 plus 4, which is 13. So in the D place for my answer, I'm going to write the number 13. The next thing I need to compute is D sub x, and the D sub x determinant has the numbers from the equal column replaced by the coefficients of the x's. So the D sub x has the numbers to the right of the equal column first, which are the numbers 4 and 7, and then the numbers in front of the y's, which are negative 2 and 3. I'm going to cross multiply down and go 4 times 3, which is 12. I'm going to cross multiply up and do 7 times negative 2, which is negative 14. And then I'm going to subtract these. I'm going to go 12 minus negative 14. The double negative goes positive, so that's really 12 plus 14, which is 26. That's 2 of the 3 determinants. The last determinant I need is the D sub y. And the D sub y starts off with the numbers in front of the x's, which are 3 and 2. And then the numbers to the right of the equal column, which are 4 and 7. I cross multiply down and get 3 times 7. I cross multiply up and get 2 times 4. And then I subtract those numbers. And 21 minus 8 is going to be 13. I've calculated the 3 determinants. To figure out what x and y are, x is the D sub x number over the D. The D sub x number is 26. The D number is 13, and 26 over 13 is 2. The y is the D sub y number over D. The D sub y is 13, the D is 13. So I'm going to do 13 over 13, which is 1. That's everything I need to show on my test to get full credit for this. Of course, if I was doing this problem to make sure you have the right final answer, you could enter this as a 2 by 3 matrix on your calculator and do RREFA. Won't get you any credit on the test, but it'll keep you from making a mistake. So I'm just quickly entered the matrix form of this system of equations on my calculator, and I'm going to do second matrix math RREFA. My answer is only right if the right-hand column has a 2 and a 1 in it. And it does, so I know I did perfectly. 9 and 10, a lot of students do all the algebra right and don't write their answers correctly. So be real careful. When we're solving a system of equations that has x's and y's, you need to pair each x with the appropriate y. I'm going to solve problem 9 using the substitution method. I'm going to start off, I'm going to solve the top equation for y, and then substitute into the bottom. You can't use the elimination method when you have exponents on the x's. So solving the top for y is super easy. I'm just going to minus x from both sides, and that's going to give me y equals minus x plus 5. And what I mean by substituting into the bottom is I'm going to take this y in the bottom and I'm going to change it to minus x plus 5. Of course, I'll need a parentheses when I'll do that. So my substituting, after I do the solving the top equation, is going to be x squared plus negative x plus 5 squared equals 13. Unfortunately, that negative x plus 5 squared could really mess me up if I don't do it right. So negative x plus 5 squared is the same as negative x plus 5 times negative x plus 5, and it's a lot easier for me to do that if I set it up to FOIL. So I'm setting up to FOIL, and then I'm going to do the foiling of clearing that parentheses in red just so it stands out. So I'm going to do firsts, outers, inners, and lasts. When I FOIL the negative x plus 5 squared, I get x squared, and then this is minus 10x plus 25. Still have the equal to 13. The x squareds both have an implied 1 in front of them that aren't written, so I'm going to combine those and get 2x squared minus 10x plus 25 equals to 13. I'm going to set it equal to 0 by minusing 13 from both sides. That's going to give me 2x squared minus 10x plus 12 equals to 0. And all the numbers here are divisible by 2. If you have a problem that has an equal sign and a common factor that doesn't have a letter, it's legal and probably a good idea to divide that common factor away. That's going to make this x squared minus 5x plus 6 equal to 0. And now I can solve this by factoring. This factors into x minus 2 times x minus 3 equal to 0. I'll set the x minus 2 equal to 0 and get an answer of x equal to 2. I'll set the x minus 3 equal to 0 and get an answer of x equal to 3. Each x needs to be paired with a y. So when I go to write my answer, the x equal to 2 needs to be paired with the y that's appropriate with it, and the x equal 3 needs to be paired with a y. To figure out the y that it pairs with, I'm going to change those x's first to 2 and then to 3. So the first time I'm going to pair a 2 with this x, I'm going to change that x to a 2. I'm going to leave the negative sign in front of it. I'm going to combine these, and that's going to give me y equal to 3. That 3 needs to be in my answer paired with the 2. Second one I'll do in pink just to separate these. Next time I'm going to plug 3 in for that x and get y equals negative 3 plus 5. That simplifies to positive 2, and that is going to pair with that. So a lot of times students will just write 2, 3, 3, 2 and not pair them together, and I have to take points off. So it's real important when you get answers for x, each x only matches with a specific y, and it's the y you get after you substitute. I think I'm going to do the same sort of strategy for number 10, meaning I'm going to solve the top for y. And substitute into the bottom. So the top equation is x plus y equals to 4. I'm going to minus x from both sides. And this is going to give me y equals minus x plus 4. And that I'm going to now sub into the bottom equation. So in the bottom equation, I'm going to change the y to a minus x plus 4. I don't really need a parentheses because that y doesn't have an exponent or a number in front of it. So I'm going to write x squared plus negative y plus x squared plus negative x plus 4 equals to 10. This plus a minus looks bizarre. I should probably have put that minus in a parentheses just to separate the two signs. And x squared plus the negative x is the same thing as x squared minus x plus 4. And then I wrote 0, but I should have written 10. I just need to set this equal to 0 by minusing 10 from both sides, and I'll factor it. This is going to give me x squared minus x minus 6 equals to 0. I'm going to factor this and get x plus 2 times x minus 3 equals to 0. I'll set the x plus 2 equal to 0 and get an answer of x equal to negative 2. I'll set the x minus 3 equal to 0 and get an answer of x equal to 3. When I go to write my answer, each x needs to be paired with the y that it pairs with. My answers are going to be points. One of the answers is going to be -2 comma something. The other is going to be 3 comma something. What I'm going to do is plug -2 and +3 in for that x to figure out how to pair it. So for the -2, I'm going to go y equals negative, and then plug -2 in for the x, plus 4. I had a double negative, so I picked up a parentheses there. One negative from the x, one negative from the 2. This is going to be 2 plus 4, which is 6. That 6 is going to go in the answer next to my -2. Next thing I'm going to do is change that x to a 3 and get y equals negative from the problem and then 3 from my answer for the x plus 4. Those numbers have opposite signs, so I subtract and take the sign of the larger and get a +1. That's the end of my answer for problem 10. We have one last problem to do, and it's graphing 4 inequalities on the same graph at the same time and finding where all the shadings overlap. I'm going to start off by graphing on a separate sheet of paper, a not so accurate graph, and I'm going to transfer what the final answer should look like onto this paper. So I'm going to start off, I should get some multiple colors here, I guess. Should have something around. Should have something around. Alright. So let me start off and just draw generic graph. I'm going to do the easy graphs first. The first one I'm going to do in pink is x is greater than or equal to 0. And this graph right here is the y-axis. And I shade right. It's a solid line because the graph has an or equal to. And this right here, what I'm supposed to do is shade everything to the right. So that's technically the graph of x is greater than or equal to 0 with a bit of detail. Next, what I'm going to graph is y is greater than or equal to 0. And y is greater than or equal to 0 is a graph of the x-axis, and I shade up. So I'm graphing the x-axis, shading up. The third graph I'm going to do is the x plus y is less than or equal to 6. I'm first going to find the x-intercepts and the y-intercepts of x plus y equal to 6. To find the intercepts of x plus y equal to 6, I'll plug in 0 for y, and that will give me x equal to 6. That's going to be the x-intercept of a point 6, 0. So 1, 2, 3, 4, 5, 6, 0. And then I'll plug in 0 for x and solve for y, and get y equal to 6. That's going to be the point 0, 6. I'm going to graph that line. And I'm going to figure out which way to shade by plugging in 2 points. I'm going to plug in the point 5, 0 and the point 7, 0 into x plus y is less than or equal to 6. So the first point I'm going to plug in is 5, 0. I'm going to go, is 5 plus 0 less than or equal to 6, plugging in 5 for x and 0 for y. That gives me 6 is less than or equal to 6, which is true. And then I'm going to do the same with 7, 0. Plug in 7 for x and 0 for y. That gives me 7 is less than or equal to 6, which is false. And my shading needs to go towards the true point. So this one, the shading is going to work out this way. Last thing I need to graph is this 2x plus y is less than or equal to 10. And it's kind of out of room here, so let me work on this 2x plus y is less than or equal to 10. First, I'm going to find the x-intercepts of 2x plus y equal to 10. I'm going to plug 0 in for y and get 2x plus 0 equals to 10. That will give me 2x equals to 10, or x equal to 5. And that's going to be the point 5, 0. So there's the 0.50 already. And then I'm going to plug in 0 for x and go 2 times 0 plus y equals to 10. That's going to give me y equal to 10, which is going to be the 0.010. And 0, 10, 7, 8, 9, 10 is up here. I'm going to connect these 2 points. I want to find out where these 2 lines intersect, but I don't have to right away. Now I'm going to figure out where to shade. To figure out where to shade, I'm going to plug in 6, 0, which is to the right of 5, 0, and 4, 0 into the original. So if I plug 4, 0 in, I go 2 times 4 plus 0 is less than or equal to 10. This gives me 8 is less than or equal to 10, which is true. And if I plug 6, 0 in, I get 2 times 6 plus 0 is less than or equal to 10, which is 12 is less than or equal to 10, which is false. I need to shade towards the true point, so for this red line, I'm going to shade towards the true point, so everything under the red line. So now if I look to find out where all my shadings coincide, I have to be to the right of the y-axis, above the x-axis, and underneath both lines simultaneously. The region of the graph that fits, it's under the blue line, to the right of the y-axis, is all this. And then where the blue and the red line cross, I have to stay under both the blue and the red line, so I'm going to stay under the red line and not go up to the blue line. And stay above the x-axis and above the y-axis. That's what my graph should look like on my answer, other than I should have this point labeled. And let me try to transfer this to this sheet. So my graphs are y-axis and shade to the right, x-axis and shade up, and then I went through 0, 6, and 6, 0 with one of my graphs, so 0, 6, and 6, 0. The other red graph went through 0, 10, and 5, 0. My shading needs to be in the first quadrant, so to the right of the y-axis, above the x-axis, underneath both lines. The final answer should look like this, but on top of that I should label the corner points. And corner points are any points along the boundary of the final answer. So this is considered a corner point because it's along the boundary of the shaded region. This is considered a corner point because it's along the boundary and it's an angled point along the shaded region. This is considered a corner point, and that point 0, 0 is considered a corner point. Corner points are points where the graphs connect the axis or where the graphs cross each other around the final shaded region. I need to find this point real quickly. It looks to me like it's the 0.42, but it may not be the 0.42. I find this point by finding where these two graphs intersect, because that's how that point was created. And the easiest, laziest way to do it is to just enter these in their matrix form and do RREFA to make sure that that's the 0.42. So to make sure my 42 is correct, I'm going to go second matrix, edit, enter a 2 by 3 matrix, and enter 1, 1, 6 for the matrix equivalent to the top row, and 2, 1, 10 for the matrix equivalent to the bottom row, and then second quit, second matrix, math, RREF, second matrix, enter, enter, and it is 42. This would be the perfect answer for problem 11. This would also be a fine answer. If this was your test question, as long as you took the time to label the 0.42, 0, 0, and you might have some extra points labeled because I wound up making some extra points as I made my graph. But the graph, the final graph, needs to have the region where all the shadings overlap the darkest. That's why when I did it on this sheet, instead of shading each line, I lined my shading. And then I looked for the region in my mind where all the shadings overlap, right of the y-axis, above the x-axis, underneath the blue line, underneath the red line, and that's what it would kind of converge on. So that's everything that we're going to need to do for this chapter. Hopefully this is a good chapter for you, and then chapter 9 should be kind of easy because there isn't a test. And then after that we'll just have the final exam. Final exam is always optional in my class, and I'll talk about in class how you can figure out whether you need to take the final, and if you need to take the final, what you'd have to get on it to get whatever grade you're trying to get.